Hi, everybody, and welcome back to Chee-Tash. My name is Chris, and today we're going to be talking about the book The Clean Coder by Uncle Bob C. Martin. Today, talking about Chapter 8, Testing Strategies. If you guys remember last time, talking about Chapter 7, we talked about acceptance testing and how acceptance testing is an effort that is supposed to be done between business and development. We talked about how acceptance tests are different than unit tests. And we talked about how acceptance tests are specific tests that will define when something is done. So it's a way to communicate when a piece of feature is done and it's able to be communicated to the business side. Remember, unit tests are for programmers, acceptance tests can be for the business side as well, so they understand what is going on. We're going to hit on a couple of these points today in these PowerPoint slides as well, so some terms are going to come back up. And I'm just going to start out with the first slide here about the roles that we face as developers in QA. And this is something that I've had to get over in the past when I've had dealings with the QA team, and I kind of see the QA team as an adversary. And I think Uncle Bob has talked about this in some earlier chapters, or maybe it was in his other book, Clean Code, or maybe it was earlier in this book that, we tend to see QA as an adversary. And that's kind of how I saw them in my career, that, hey, they're basically creating more work for you by finding like these little inconsistencies, these little bugs. But at the end of the day, you're all on the same team and you're all trying to make the app work. It's everybody's project here. Everybody's a part of it. At the end of the day, you should have the app working so flawlessly that QA should not be able to find anything wrong. That's always the best case scenario. But Uncle Bob says, obviously, this doesn't happen very often. So in the times that it does happen, or I shouldn't say it doesn't happen very often, but it doesn't happen every time. That's what I wrote there. And if QA does find something, this is the time to reflect and ask, well, how did that happen? And what do we need to do to rectify the situation? Uncle Bob has talked about in previous chapters how when a bug does show up, that you should jump on it right away. It should be a whole team effort to just jump on it, or at least put somebody on it to fix it right away. That should be priority number one. And again, QA, they're just a part of the team. We're supposed to work together with QA. They are just as much a part of the app's functionality and the final rollouts and what the customer sees. We're all a part of that. The business side, the dev side, the QA side. And QA's role here, and this was interesting, Uncle Bob says that the QA role is boiled down to two things. They're specifiers and characterizers. So as a specifier, they translate business requirements to tests. And this is where the acceptance tests come in. So they work with the business unit to determine automated acceptance tests. So this is so the business team understands what the changes are being made to the app and what the tests are going to be doing. But QA is also a characterizer in that they identify the actual behaviors of the system. So they specify things into tests, but then they also identify the behaviors of the system as well. And all this to say that we don't just have unit tests, and we don't even just have acceptance tests. And there's a hierarchy of tests that go on and happen throughout the development cycle. And they're organized from top to bottom, from coverage, from most coverage to least coverage, from maybe from more behind the scenes to more above the scenes, I guess is one way to say it. Behind the scenes in that, like, they're more so for the programmers. If you go up the pyramid, they're more for other people on the team and in the business unit to understand. And this is the hierarchy right here. And we can see The type of test, we have unit tests, component tests, integration tests, system tests, and then exploratory tests. And we can see the coverages on the right-hand side, that number there. And we know this with unit. We know that from unit tests that these should be 100% covered because they are like little pieces of documentation for your program. They are written for programmers by programmers, and they specify the system at the lowest level. So you are writing tests for certain lines of code, and to ensure that those certain lines of code are going to display the functionality that you think they should. In these cases, like I said earlier, coverage should be 100%. And it's one thing to have coverage, but it's another thing to have your test specify feedback. And that's what Uncle Bob says here. Your unit tests should give you feedback. This is why you use assertions. And there's many different assertion. I don't know if there's many different, but there's a few assertion libraries out there that you can do this, where you assert the results of calling a function. Assert true, assert false, assert greater than, assert less than, assert null, assert non-null. And your test should be able to give you feedback, because you could just write a test that just executes a function that you're testing, but then that's all it does. So you can get past it with the coverage. You could say that it's covered, but the test isn't really telling you anything. So make sure to have assertions in your unit tests. Going up the pyramid, next we have component tests. Now, component tests are written against the components of the system. So they're like little bits and pieces of your code. And when I think of component here, I think of like in React, if you have components in React or Angular, and you're testing out like a specific component, like a button, like maybe you have a button or like an input component. And the components encapsulate business rules within them. So you pass input data into the component and then gather output data from it. So this could be, maybe you do have your own customized button component, and the button component has certain maybe API calls when you click it. So you have a test that renders the button, simulates it being clicked, and then you can verify the API calls from there. These tests are written by the QA with help from the business unit. Now, the way that I'm describing it here is something that actually we do as devs on my team. So I would say actually on my team, we write these tests, but Uncle Bob here is saying they are written by QA with help from the business unit. And I can definitely see that, because these tests are written in a different sort of format. In one way, they're written in a different sort of format. They can use testing suites, or what would be testing libraries, maybe that's a better way to put that, such as Cucumber. So in Cucumber, you write tests in a Cucumber file that contain the following syntax: a given, when, and then scenario. So if, given a customized button component, when you click on it, then it should produce this. And then you write the code to suffice those steps. Those are component tests. And just a little tidbit here, they are geared towards mostly happy path scenarios. But at the end of the day, these tests, the business team should understand these more than the unit tests that you're writing. Next, we have integration tests, which test out the more larger scope of your app. And these tests test how well a group of components interact with each other. And Uncle Bob uses a phrase here that they test how well components dance together, and it's like a choreography. They don't necessarily test business rules, but they test the cohesiveness of your app and larger paths or larger flows of your app. So maybe, you have a button which is on a page, or you have a button which is within a dialogue which is on a page. So maybe you test out that entire page and the dialogue and the button maybe all together just to make sure how synchronized they are when their functionality is called into use. These tests are typically written by system architects or lead designers, but they are not something that should be part of your CI/CD cycle, as they can sometimes take a long time to run. So typically, if you make a commit or, you commit code and you push it, it kicks off your Jenkins pipeline. So the pipeline builds, it can maybe produce jar files. It then runs all your unit tests and your other maybe E2E tests, and your integration tests are not always going to be part of the CI/CD cycle, or else that pipeline would take so long to run. So those are integration tests. System tests are going to test out your entire integrated system, and they are here just to make sure that the entire system works well together. Oops, sorry about that. And again, these are going to be executed relatively infrequently as well, just like the integration tests are. But again, they just ensure correct system construction. So they are even greater scope. I would maybe even say that this is like really testing out your whole app, or testing out like a whole entire, I don't know, maybe like a whole entire flow, but really like booting up the app and actually testing out the flow from running your app. So it's more so than just a bunch of different components working together. It's your whole app, and then running the business flow, testing it out through the app. And then lastly, we have these manual exploratory tests, which are not automated and they're not scripted. They're more so there just to bug hunt. And it's something to be done by everybody and anybody. Anybody can do this. It's not going to be done often. And even the coverage, it's at the top of the pyramid, so it's the least covered of the tests, because the coverage is not the goal. The goal here is to make sure the system behaves well under regular operation. So this is literally you demoing, you putting out your app or software to an end user and demoing it to the user. And then they can report back if they find anything that's misaligned or any bugs or anything that's up with your app. And the important thing here is that anybody can do this. So you could see at the base of the pyramid, that stuff's more for programmers. And then as you go up and up and up, it's like anybody can do this, or the tests are really there to communicate to anybody out there. Excuse me. So anybody can do this. It doesn't have to be devs or the QA team or the business team. Think about like end users of people that aren't even a part of the software process. You can just ask a friend, hey, can you just test out this app? Let me know what you think. Something like that. So we learned about here, we've got the hierarchy of testing strategy with unit tests, component tests, integration tests, system tests, and manual testing. We can see how some are frequently ran, like unit tests should be frequently ran and they should run fast. And then we saw how we go up the pyramid, the tests get a little bit slower and slower because they're testing out more and more things. And we talked about how it's important that your tests provide feedback. And it's not just about the coverage, it's about, hey, if I do this, then does this happen? Talked about like in the component test, given when and then scenarios, but your test should provide feedback. And at the end of the day, I think that's maybe one of the most important parts about having a testing strategy is what feedback are you getting from those tests. So that's going to do it. Thank you guys so much for listening. We'll be back in a couple weeks just because I've got a couple interviews, cool interviews to prepare for coming up. So I don't think we'll have a video a week from when you listen to this, but we'll be back again in a couple weeks, guys. Thank you very much for listening. Again, my name is Chris. This has been Chee-Tash. Take care, everybody.